We've already looked at contingency tables before, and we looked mostly at percentages. Now we're going to look at it in probability notation. So we are going to, instead of giving percentages, we're going to give decimal numbers. We're going to calculate the probabilities using the contingency table. So the question that was asked over here, are people happy in their marriage? You can see the results over here from a survey in 2002. And we can see the gender is one of the variables, and the happiness is the other variable. So the gender is displayed in the rows, and the happiness is in the columns over here. So what is the probability that a randomly selected married adult is male and very happy? So we have these keywords over here like and, which shows us that we're looking for a joint probability. So we can highlight the males, and we can highlight the very happy, and always means it has to be both at the same time. Therefore, it's all 220 males that are also very happy. So joint probability on a contingency table means the joint cell that is both of them. And it's 221 very happy males out of 603 people altogether. So and probability always gets divided by the grand total. We can then write it as a decimal number, which is equal to 0.3665. Most of the times we round probabilities to 3 or 4 decimals. So just let's keep that the same. The next question is asking, what is the probability that a married adult is very happy? So over here, we are just looking at whether the person is very happy or not. Looking at married adults, that's both male and females. So we have 370 very happy people divided by our grand total of 603. As we did in the activity before, whenever we're in the totals of our table, we call this our marginal distribution or marginal probability, marginal percentages. And here again, 370 is the total of the very happy people divided by the grand total. And when we simplify that as a decimal number, we get 0.6136. Again, rounded to 4 decimals. The next question is asking, what's the probability that a married adult is male or very happy? Okay, so this time we have the keyword or, and we're going to highlight again all the males. We're going to highlight all the very happy people. But this time we're asking for or, and in math, when we're looking for or probability, it looks either at whether a person is male or a person is very happy, or they could be both. So or is always inclusive of and. We call this the union of two events. So over here we have a number of ways of calculating this. We could take the grand total of the males. We could take the grand totals of the very happy people, but if you add those two together, we would have to subtract out the very happy males that were counted twice. So another option we have would be to take the grand total of the males and then just add the very happy females that we haven't counted yet. So that would be adding up all the values in such a way that nothing is counted twice, right? We first took the total of the males. We could also have added, the 3 different columns over here for the males. And then we're adding the females that we haven't counted yet. So that would be 325 for the males plus 149 for the very happy females divided by the grand total of 603. So all 3 of these probabilities, joint, marginal, and union, always divides by the grand total. And when we simplify, that is equal to 0.7861. And then we have one last type of probability, and I'll erase our table again here. So the last probability is asking for what is the probability that a married adult is very happy given they're male. So this is usually the probability that people struggle with the most. It's called conditional probability. So meaning we're not looking at everyone in our table anymore. We are going to look only at the male ones. So we're always going to look for keywords like given. Sometimes we have off or if. These are all common keywords for conditional probability. So given that the person is male, we're going to highlight the male people in our table over here. So given the person is male, we want to know the probability that they're very happy. So that means out of our 325 males, 221 are very happy. Again, given means we're going to just restrict our people to the males only. We already know the person is male, and therefore we're just going to find the very happy males and divide them by the males altogether. So that gives us 221 out of the 325. And when we simplify, that is 0.68. All right, so for notation for these events over here, when we have the joined probability, we could call this male and very happy. And we could use different words for that. But this is actually the intersection symbol, which stands for and. The marginal probability, it's just a probability of very happy, so you'll notice there's only one event listed over here. For the or, we have another symbol, which is male or very happy. We call this our union symbol. And then the last one for the probability, for the conditional probability, we use a slash to stand for the given. So that would be happy given male. So we just read that as given. Again, the first one is the intersection over here. Very happy is a marginal probability, so we just list one event. Union is like a U symbol, and then the conditional probability, we use a slash. These are all 4 types of probabilities that we can calculate from a contingency table. It's also the 4 probabilities we can calculate of any event. We've looked at most of these in the context of stop and frisk before, but instead of looking at decimal numbers, we looked at percentages. So this should be somewhat familiar. And conditional probability is usually the one that gives people the most trouble because they forget to adjust the total, or sometimes they use the wrong total. So you always have to read it very carefully. You want to highlight the conditional part, the given part, the part you already know, and then out of that row or that column, you're going to find the event you're looking for.